Just prove that gamma p plus 1 equal to p into gamma p, and then gamma n equal to factorial n minus 1, where n is a positive integer, that is 1, 2, 3, 4, dot, 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 dot. So we start by definition of gamma p. Gamma p is defined by the integral 0 to infinity e to the power minus x, x to the power p minus 1. So gamma p is defined as the integral 0 to infinity e to the power minus x, x to the power p minus 1 dx. Now let us apply integration by part. We regard x to the power p minus 1 to be first function. So let's write the integral once again. E to the power minus x, x to the power p minus 1. Let's regard this to be first function, and e to the power minus x to be second function. So by integration by part, what we have is, let us apply integration by part. First function we write as it is, first function into integral of second function, integral of e to the power minus x minus integral of derivative of first function. So d dx of x to the power p minus 1 into integral of e to the power x dx dx. We need to do it twice. So x to the power p minus 1, we write it as it is. E to the power minus x, if you integrate it, you get e to the power minus x by minus 1. So we need to compute the limit from 0 to infinity, but if we can't put the value infinity, so we just write limit from 0 to x and x tends to infinity. Minus d dx of x to the power p minus 1 is p minus 1 into x to the power p minus 2. P minus 1 into x to the power p minus 2. Integral of e to the power minus x is e to the power minus x by minus 1 dx. Now as x tends to infinity, e to the power, okay, let's write it as slightly different form. Limit x tends to infinity, x to the power p minus 1 minus of x to the power p minus 1 divided by e to the power x. Then 0, if you write 0, you get 0 only. We assume p greater than 1. So this identity is valid only for p greater than 1. So our proof is valid only for p greater than 1. Minus minus will make it plus. P minus 1, that's a constant of integration that we can take it out. Integral x to the power p minus 2, x to the power p minus 2. Let's write it as p minus 1 minus 1 into e to the power minus x into e to the power minus x dx. Observe that as x tends to infinity, this quantity tends to 0. So 0 plus p minus 1. We have started with gamma p, so let's write gamma p to the left hand side, equal to p minus 1 times an expression. Can you see that this is x to the power p minus 1 into e to the power minus x. Oh, I forgot to write the limit 0 to infinity. Here also 0 to infinity. Now, this, if you look at it, once again let's look at the definition. E to the power minus x, x to the power p minus 1. And what we have here? E to the power minus x, x to the power p minus 1 minus 1. So isn't it equal to gamma p minus 1? Yes. So we have proved the identity gamma p equal to p minus 1 into gamma p minus 1. Of course, p has to be greater than 1. Next, let's take p equal to 1. Take p equal to 1. Gamma 1 equal to, let's take p equal to 2. Gamma 2 equal to 2 minus 1 into gamma 2 minus 1. That's 1 gamma 1, that's gamma 1. Now gamma 1 equal to, again by Euler's definition, Euler's integral of second kind, 0 to infinity e to the power minus x, x to the power p minus 1, 1 minus 1. Gamma 1 equal to integral 0 to infinity e to the power minus x, x to the power 1 minus 1. X to the power 1 minus 1 is x to the power 0, x to the power 0 is 1. Integral of e to the power minus x is e to the power minus x by minus 1. Limit from 0 to infinity. We can't write infinity itself, so we write limit x tends to infinity e to the power minus x. That's equal to minus 1, we take it out, and upper limit we have e to the power minus x, lower limit we have 0 minus e to the power 0, that is 1. Limit x tends to infinity. How much is this? X tends to infinity, e to the power minus x tends to 0, and minus 1 is plus 1. So gamma 1 equal to plus 1. Now let's use the identity gamma p equal to p minus 1 into gamma p minus 1. So gamma 2 equal to 2 minus 1 into gamma 2 minus 1. That's 1 gamma 1, but gamma 1 is 1. Similarly, gamma 3 equal to 2 gamma 2, and gamma 2 we got it equal to 1. So 2 into 1 is factorial 2. Similarly, gamma 4 equal to 3 gamma 3, that's 3 into factorial 2, and that's equal to factorial 3. If we continue this way, we'll have gamma p equal to p minus 1 factorial.